Okay, question number C from the previous video. That's what this is for September 3rd or September 4th. Okay, 4th September problem. This has around 11 marks. So what I'm going to do is I'm going to continue it for 11 marks, 11 minutes. Let us see if I can finish it in 10 minutes or maybe it takes more. Let me try it out. Okay, let me start the timer. A large swinging ball is used to drive a horizontal iron spike into a vertical wall. So the large swinging ball over here is going to hit this one here, and there's a nail which is being kept over here. The center of the ball falls through a vertical height of 1.6 meters. It falls through a height of 1.6 meters. Okay, so this height it falls down. The center of the ball falls, okay, and then strikes the spike as shown. Okay, the moment it strikes the spike, what happens? This will be nailed inside the wall. Okay, the spike mass is given, the ball mass is given over here, right? And then what is he asking here? He is asking you the mass of the ball is 3.5 kg, mass of the spike is 0.8 kg. Immediately after striking the ball and the spike move together. The moment it comes and hits this one, both of them start moving together. Maybe it will move for some time and then it will come back over here. At least by doing this, it will be nailing this nail into the wall by a certain distance. Okay, then what is the question here? What is the speed of the ball and striking the spike? Show that the speed of the ball and striking the spike is 5.6 meters per second. Which means he is telling you the moment it comes and hits here, this velocity, even though the nail has not completely gone into, this velocity, moment it hits here, is seen to be 5.6 meter per second. So how do we do this? Is the question. Now what we do is, let me go back to this. So this is only for 1 mark. Now I need the diagram. Without it you can't do it. So you see, what is the energy here? The energy here is half mv square, right? Okay, so initially you are dropping it here. Now it's at a height h. It's at a height h. Let me use this as a reference level. So therefore, the height h is 1.6 over here. The potential energy at this point is nothing but mgh, right? When it comes and hits here, what happens? All the potential energy has got converted into kinetic energy, which means what's the energy here? It's half mv square. Now with this, what we do is we can equate it. Okay, there is no air resistance, nothing is happening over here. You can write mgh is equal to half mv square, where v is the speed of the bob at this point. So this m and m goes away. We are not concerned with this m here. Okay, we are only looking at this. So v square should be equal to 2gh, right? Let me scroll it a little bit. So v square equal to 2gh. Let us substitute this value, which should be 2 into 10 multiplied by 1.6. Where is this 1.6 coming from? Coming from here. Okay, which is equal to 2 into 1.6. 1.6 into 10 is 16. This should be 2 into 16. V should be equal to square root of 2 into 16, which should be 4 root 2 should be your answer. 4 root 2 meter per second. So if I substitute this is 4 into 1.4, 4 4s are 16, 1 4 1s are 4, 5.6 meter per second. So what was the question over here? It says speed of the ball striking the spike is 5.6. So you have got the 5.6 meters per second, right? Okay, the first part is done. The energy dissipated as a result of the collision is about 10 joules. You have to show them. Okay, that the energy dissipated as a result of collision. Why does the energy get dissipated? Because the moment it comes and hits over here, either there could be an air resistance or maybe there is a bang which you hear. Okay, so all this together will dissipate some amount of energy. Now, towards it, how do I do it? The first thing is that when it hits here, now what's happening over here? So 5.6 meter per second is the velocity at which it hits here, right? So now the problem truncates to something like this. Okay, you have the ball over here and you have an object like this over here, which has a sharp teeth like this, and this is what you have. So when it hits over here, now this velocity, incoming velocity v1 is equal to 5.6 meter per second, and then this is your m1. What is the mass of this? What is the mass of this? The mass of this is seen to be mass of the ball is 3.5 kg. Mass of the ball is 3.5 kg. 3.5 kg. And similarly, what is the mass of the spike? Mass of the spike m2. What is its value? What is the value here? Mass of spike is 0.8 kg. 0.8 kg. And what is the value of v2? The mass of the velocity of the spike. Initially, before this came and hit here, the spike was not moving. So v2 equal to 0. Then when both of them joined together and started moving inside, right? So therefore, the combined mass of this after colliding is nothing but m1 plus m2, m1 plus m2, which should now be equal to 3.5 plus 0.8, which is 4.3, and then it is now moving with a common velocity v. So this is what we have. Now we can apply conservation of momentum. If you apply the conservation of momentum, what do we get? m1 into v1, 3.5 into 5.6 plus m2 into v2, 0 is equal to m1 plus m2 into v. which should be 4.3 multiplied by V, right? So we can get the value of V. V will now be equal to 3.5 into 5.6 divided by 4.3. Let us find out what is this value. Let me take my calculator. So I will use, what is here, 3.5 star 5.6 divided by 4.3. I get the answer as 4.55. Okay, so I get the answer as 4.55 meter per second. So there is no square, it is just like this over here. Okay, now what I can do is I want to find the initial kinetic energy, because he is asking you energy dissipated. Okay, so initial kinetic energy, Ki initial, before it hit the collision, was nothing but half into 3.5, the mass of the bob, multiplied by V square. What is V square? 5.6 square, right? And what is kinetic energy final? Kinetic energy final is nothing but half into, what is the combined mass? Combined mass is 4.3 multiplied by, what is the final velocity? 4.5 square over here. Okay, let us calculate these two also. So I will do this as, I will do this here. So I will have, let me pull this a little bit. Yeah. Okay. I will have 3.5 star 5.6 star 5.6 is equal to so much, divided by 2 will be 54.8 joules. So this will have an equation equal to 54.8 joules value, and the final one is nothing but 4.5 star 4.5 star 4.3 divided by 2, which is equal to 43.53 or 43.54, 43.5 joules over here. Now what do I need? The difference in energies, the difference between these two, delta kinetic energy. This will give me the loss in kinetic energy, right? Which should be 54.8 minus 43.5. When I do this, how much will this be? Let us do this also. 54.8 minus 43.5. When I do this, I get 11.3 joules. 11.3 joules. So which is closer to 10 joules. I think we made some calculation mistake somewhere. That's why we are getting a difference over here. Actually, this should be 4.6 joules. Let us find out what is the answer I get here. V is equal to 4.5. I'm sorry. This is 4.56 you get here. Approximation will give you 4.6 over here. So therefore, if I do this, what do I get here? I get this answer as 4.3 star 4.6 star 4.6 divided by 2, which will be 45.49, which is 45.5. I did it correctly. Okay, 45.5. I am sorry. This is 45.5. 45.5. So 54.8 minus 45.5. I should do it. So 54.8 minus 45.5 will give me around 9.3 joules. Sorry, this is 9.3 joules. Thus the answer is close to 10 joules, right? So how many marks does it fetch? It gives you 4 marks. What is that you need to write? First is you need to elucidate what are all the basic parameters. This will fetch you 1 mark, right? Then COM, this will fetch you the second mark, and get the value of V. This will fetch you the second mark. Okay, and third mark, finding out kinetic energy initial, kinetic energy final. This will give you the third mark. And last one, getting the value nearly equal to this. This will give you the fourth mark. Okay, let me stop the video for a moment. It's already time, so it's getting, my ring light is getting heated up. So what I will do is I will continue the next question in the next video.